So from the first part of this video, which is the previous post that I made, we clearly stated the goal of this project, including the project overview, problem statement, data set exploration, right? And then we downloaded our important libraries. For dataset cleaning, we're also basically going to be using mainly NumPy and Pandas, so I will not be introducing any new libraries right now. So we went on, we explored the data set, we were able to notice patterns, we identified anomalies, we observed distributions, we understood the stories that each column was telling us and the relationship also between these columns, that's between these features. Yeah, and we're able to make some major observations, some of which are here on the screen. They're also clearly stated out on the previous post. So all the observations we've made, right, they have clearly informed us on how to properly clean this data set. So let's quickly get into it. Now, data set cleaning, the very first thing I did, which is this first code you're seeing here, was that, okay, at the very beginning, I started with my column names, right? I decided to standardize my column names, right? Which meant transforming them to snake case, making sure that they were in snake case, naming. Now, why am I using snake case, right? For several reasons, but I will give two. Number one is that with snake case, I can easily manipulate my data. I can easily access my columns using the dot notation, Also, the second reason is to avoid compatibility issues, right? So snake case is like the most compatible name casing with major Python libraries such as pandas and scikit-learn, also with machine learning algorithms like XGBoost, right? So it's really compatible with snake casing. Like I said, there are many other reasons. So what I did was, starting with my column names, of course, renaming them, because any other thing I'll be doing, I'll be referring to this column. So I decided to fix them first, right? So here you can see that I stripped any leading or trailing spaces that could be in my column names, right? I used the data frame string method and I used the strip operation for this. Then I went on to convert all my column names to lowercase, basically, right? Again, I used the string method and I used the lower operation. If you can see, I keep assigning these changes back to the data frame columns, right? So that this change should be effected like permanently inside of the data frame, basically. Then I came here and I replaced all the dashes or the hyphens with the underscores, right? And I came here to print out the columns again to see if my change has been affected, and we can see it has been affected. Everything is in lowercase, and the dashes that were here before, they've now been replaced with underscores, right? So now all of our column names are in snake case. The second thing I did in my data cleaning was to remove any trailing or leading white spaces in my categorical columns, right? And I created a for loop so that it will iterate through all of the categorical columns. So this object is the data type for categorical columns. So I'm doing this showing that I don't want it to apply this to the numerical columns. Why? Because automatically numerical columns, it doesn't even allow any, trailing or leading white spaces to be there. So yeah, that's what I am doing. I'm removing any leading or trailing white spaces in this in my categorical columns. And now, before I proceed, right, in case you have not noticed yet, when we explored this data set, number one, there were no trailing or leading white spaces in my column names, same as the entries in the categorical columns too. Number two, my column names were already in lowercase, right? So you may ask, why am I still doing this? It could be like, this is just repetitive, I'm just overdoing, right? But I'm doing this, right, for preventive measures. Number one, I want to ensure uniformity, maybe in case if there's anything I missed out, because I want everything to be uniform. Number two is really to avoid any future inconsistencies, because this data set could really be updated, right? Maybe there could now be some column names that are not in underscores, some categorical entries will now have leading or trailing white spaces. At the end of the day, I want to have a very robust and reusable code. So that's why I'm doing this. Again, it does not harm my data set in any way at all. So why not? If not, then I simply went on to check the number of duplicates, right? So you would notice that I had several duplicates checks. To me, I was calling this sanity check because I wanted to keep note of all of my cleaning process. and see the change that they cause as they are causing. I don't want to be caught off guard. I also just want to monitor it. So far with everything I've done, my number of duplicates are still 48, which simply confirmed to me that no entries had any leading or white spaces, so I was just being extra, and I have given my reason for that. So the next thing I did was to drop irrelevant column. But before that, there's something important that I should note, right? In this dataset cleaning, there's actually feature selection and feature engineering in it, but it's kind of, I don't know if to say it's a bit like salient in a way, right? Because it is not the major feature selection and feature engineering for our modeling, right? We are going to do more of that when we want to create our model, but for now we're doing enough that we would be needing for our exploratory data analysis, right? So I went on to drop the final weight column. This is a particular census weight, right? And it has no predictive value really for my income, which is like the whole goal of this project. So I decided to drop this column. You can see it here. I specified that it should go to the axis axis 1, that's the columns. It will find this and it should drop it. And again, you can see that I'm assigning it back to the data frame so that the change should be effected. So I'm just dropping the column so that I don't waste my time, energy, and resources, cleaning or analyzing a column that I don't need. So I dropped the final weight column, and then I went on to print out the number of columns again to be sure that the final weight has been dropped, and clearly we can see that it has been dropped. Now the next step in my data cleaning was that I handled missing values, right, and also odd entries. If we can remember, during our dataset exploration, there were 3 particular columns that were affected by this. So they had missing values, they also had the odd entries, or we can call it like the placeholder, sorry, question mark. And these 3 columns were work class, occupation, and native country, right? So the very first thing I did was that for all of the entries that had only question mark in them, these placeholders are non-informative, right? And leaving it in my data set, that's including the null values or the missing values, is just going to disrupt my the distribution of my categorical values, right? And it's not going to do me any good. So I can decide to either drop the rows or impute them with other values. But let me just convert. So here I created a for loop, right? You can see it here, that converts all of the odd entries. So every entry that is a question mark, I use the NP-NaN. This is a numpy, not a number, what you're seeing here. So it's simply a special marker for null values used in numpy and pandas. This in place true that you're seeing you can relate it to the same thing that I was doing here when I was reassigning this change back to the data frame. So in place true just means that I want this to be effected in the data frame, right? So now I have all of my null values in one place and I can access them. You can see that the number of null values in these columns now have increased because I converted all the question mark to null values, right? So I went on to print the new number of null values in my data set, and we can see it has increased. Now, like I said, we can decide, do we want to drop these rows or do we want to impute these null or missing values? Now, number 1, I did not drop these rows, and I will give my reason for that, right? And also, number 2, I did not just leave them empty like that in my data set. Now, why did I not delete these rows? These rows that have missing values in these 3 columns, they also have very, very important information for the 11 other columns that are inside this data sets, right? And you know that our data set is very imbalanced, right? The minority group, which is people earning greater than 50k per year, they are very underrepresented. So if I just delete these rows for this reason only, it does not make sense, and I'm at the risk of losing very, very important information. So that is why I did not delete the rows containing the missing values, because it affected only 3 columns, right? Now, what did I do? We can come here and see I filled out the missing values in these columns with the mode of each of these columns. Why am I using the mode? The mode is like the frequently appeared value or category in these columns. Why am I using the mode? Because the mode preserves the integrity and the distribution of the columns, right, and the whole data set. So during our data set exploration, the mode for the work class, that's a frequently occurring group, it was private. For occupation, it was prof specialty, and for native country, it was United States. So yes, I replaced all the missing values with the mode of their columns. Then I went on to print out using is null.sum, this data frame method to check if there are any other null values or missing values in my data set, and you can see there's nothing. Again, I clearly stated out my reason for handling these missing values, which I have, said. Then again, what I call my sanity check, I decided to check the number of duplicates, right, to see if the change, what I just did, that's replacing the missing values, did it affect the number of duplicates? And surely it did. We had 48 duplicates initially, but now we have 6,604 duplicates. Why? Because some of these entries were empty, but now I have imputed new values inside, so it has made it like identical with other rows. But we're not handling duplicate now yet. We'll handle it when we're done with our cleaning. I decided to check the shape again to be sure. Like I said, I was just making sure that I am not caught off guard if I have messed up anything in my data set. So we still have 48,842 rows and 14 columns, right? Next up, what did I do? I decided to convert my target variable, right, from categorical data type to numerical data type. So yes, this step is not really necessary at this point, but like before my modeling, I would still encode this column, right? I could actually even use like a label or encoder, but at the end of the day, it's the same thing you need to do. It will convert the values into zeros and one, and it's only two groups that we have, so of course one group will be 0, one group will be 1. I did this earlier on because I just wanted it to be this way too for my exploratory data analysis. Like I said, I did not really have to do it at this point, but I decided to. So yeah, I replaced all the less than 50k with zeros, and I replaced all the greater than 50k with 1. And then I simply came here to check the unique values in this column, and we can see that it's only zeros and ones, right? Yes, so the change has been effected. Again, I printed out the number of columns because every step I was just making sure that everything is good. I have not messed up anything. I have not deleted anything. Now, the next step I took in my dataset cleaning was to handle the cardinality in some of the columns that we noticed, right? Some of the columns had many entries, many categories, and some of these categories even had like really few entries in them, right? Now, grouping them is going to really help my EDA, and it's also going to help my model performance, right? Number one, for the EDA, it will help me to have clear trends, right? And clear trends will give me more meaningful insight. And then for the modeling, it's really going to reduce sparsity and also like prevent overfitting, right? So that is why I am grouping this. So let's get into it so that we understand this better. Again, you can see that I am accessing these columns with dot notation. So I'm just doing df dot the column. You can see for native country, right, if it were a dash or a hyphen that was here, this will not work. I will not be able to access this column in this way, like this. Of course, it's not the only way of accessing it, but this is how I wanted to. Again, you can see that all of the changes that were happening here, I was reassigning them back to this column so that the changes will be effected in the columns in the data frame, like perfectly, permanently. So you can see for the work class, all of the people that were working in local government, state government, and federal government, I grouped them as government. Those that were self-employed, incorporated, and self-employed, not incorporated, I grouped it as self-employed. Those without pay and never worked, I grouped them as unemployed. Now for the education, there were particular groups, there were so many, and all of them had not finished high school, so I just grouped them in one place. So all the preschool, 1st to 5th grade, all of them, so from the very 1st grade to the 12th grade, I just grouped this category as low. Then HS grad, these are people that graduated high school, right? I just converted that to high school. And then associate academic, associate vocational, I made it associate. And then for prof and doctorate, I just made them highest. So we can see clearly how I have grouped this. You can also check for native country, right? I grouped all these countries as North America, these ones as America and Caribbean, these countries as South America. I just grouped them into their regions, really, right? And then I went on to print the unique values in these columns that I have just worked on, right, to see if they have been properly grouped. And we can see now that they have been properly grouped. Then the very last thing I did was to handle my duplicates. Now I decided to drop my duplicates, and this was a bit of a challenge for me, right? Because I was thinking, should I drop the duplicates? Should I not drop them? But at the end of the day, it's always quality over quantity, because in my mind I was like, this is close to 7,000 rows I'm going to drop. It's not going to affect the data set, but always remember, it's always quality over quantity. So I decided to drop my duplicates, right? Yeah, so I dropped the duplicate. You can see here I dropped the duplicate, and I decided to check if there are any duplicates at all in the data set, and we can see here that there are 0 number of duplicates. And then I decided to check the new shape of the data frame. We now have 41,938 rows and and 14 columns. And of course, I stated why I dropped my duplicate. So if I dare say, I can say that our data set is now squeaky clean and ready for our exploratory data analysis and modeling. So see you guys in the next video.